Hi everyone. So my talk today will try and answer the question, can Gen AI be trusted with numbers? As market research professionals, it's very important that we deliver accurate results, right? And we had a talk earlier that if we don't deliver to our clients accurate results, then trust is gone, and then they will never buy research from us again. So very important. I'm Guillaume. I'm co-founder and CTO of Inspirient. At Inspirient, we're building an AI that can analyze quant data. My background is I have a PhD in computer science. It's applying machine learning to the problem of speech. I was essentially trying to build an AI that could learn language like a baby learns language. So it was a lot of fun. And then I got a job as a management consultant at Deloitte, where I worked. Yeah, that's how it goes. But I did do a lot of kind of data science projects, and it was a lot of fun. But essentially, that's where the idea came from for the company. We found, myself and my co-founder, he was actually at the Boston Consulting Group, and we found that we were spending way too much of our time kind of pivoting data in Excel and drawing PowerPoint charts. And we thought, well, surely there must be like the self-driving car of analytics. And so that's where the idea came from, and we started that in 2016. So, this talk, can generative AI be trusted with numbers? I think we all agree that kind of large language models can't fully, but I say yes. Okay, so the talk's over. We have the conclusion. However, it can't be done with LLMs alone. And, well, I'll explain why, but just to point out how bad it really is. So, back in 1994, Intel released a processor with a hardware bug in it that had a 1 in 9 billion chance of getting a floating point division wrong. And it was kind of rounding error. And that caused massive problems for them. So much so that they had to do a product recall which cost them $500 million. And in the beginning, they were actually saying, well, there's so little chance of it occurring that it doesn't matter. But they received a massive backlash, and yeah, they had to recall them, and it cost them a hell of a lot of money. And today, or at least in 2024, Google Gemini or similar models, they have a 1 in 2 chance of getting a math problem wrong. So the joke's on us, right? So why is kind of large language models so bad at maths? Well, they weren't really built for maths. But if we try and do maths with them, there's kind of 2 ways that we can do that. The first is just using the underlying architecture, neural networks. We can essentially try and predict what the answer will be based on what we've seen in the past. So simple arithmetic, all the times tables, it's seen so many examples of that, it will get them right in most of the times. And so, yeah, essentially they're trying to predict the answer and not really calculate it. And so the negatives, you get sometimes correct answers, sometimes incorrect answers, and also if you've used large language models, depending on how you ask a question, you'll also get a different answer, so it's not reproducible for the same mathematical kind of question. The second alternative is to use large language models to write code for you that can then do the arithmetic. And that's fine, but LLMs will also make errors in generating code. Depending on how complex that code is, there's a chance of it having 50% of that code containing errors. And so every time you ask a maths question and it's generating code in the background, who's reviewing that code? Who's checking that that number was actually what you intended? And so the more complex that maths question becomes and the more code it generates, the less and less reliable those results are. And Andrew and Cameron were showing that earlier a little bit. So they weren't generating kind of Python code or anything like that, but generating API calls and then restricting the kind of flexibility of what could be asked, that you actually reduce the error rate, and so you will get accurate results, but you lose that flexibility of being able to write code. So essentially what we're trying to do with a large language model is use a hammer when we need to screw it in. So what's the right tool? Well, we know that neural networks aren't. They were developed in the 1940s. You get probabilistic results, so introduces hallucinations. They're not reproducible, the results. There's no paper trail. It's a black box. It's expensive to operate and difficult to build. In the 1950s, we came up with expert systems. And so they are stable, they're deterministic, they have granular reasoning steps, we can control them, and they also can run on commodity hardware, but they are also very difficult to build. So what would an expert system look like that could analyze quant data? And so if we have, let's say, we want to feed it raw respondent level survey data, then we would need to, first of all, essentially create components that could infer the information in that table. So it would detect a table, and then it would look in every column and say, do I have string values? Do I have numeric values? Do I have currency? Do I have date? And then at that point, we could also say, okay, well, we have 99 out of 100 of the values in that column contain numeric. One of them is string. We could say, well, with a 99% confidence, that is a numeric column. And at that point, we could even infer that it is a numeric column and ignore the row or the cell with a string. And then we can also track that at every step and essentially do data cleaning in a transparent way. So we have the type classified. The next set of classifiers would be, do the columns contain names? Do they contain zip codes? Do they contain cost? And any kind of semantic inference that we can make, we can add classifiers for those. Then once we understand the meaning, we can then analyze the data appropriately. If we have a set of independent variables, a set of dependent variables that we've classified, we know, well, we can do crosstabulations of them. If we detect two numeric columns and it makes sense to do a correlation analysis, we can do that because we've understood it from the bottom up. We can do time series if we have dates. So once we've done all the analyses that make sense, we can then start doing more advanced stuff, some pattern detection, driver analysis, and essentially work through the whole process that a human analyst would take to import data into Excel, pivot it, look for patterns, and then create some slides. So that's what a kind of expert system for analyzing quant data looks like. So we have the raw data, we push it through the expert system, we have results, and these are comprehensive results, right? So if the expert system has detected 5 independent variables and 100 dependent variables, it's going to do a cross-tabulation of every single combination and generate hundreds of crosstabs. Now, this is where the interesting part comes in. we have so many results, we don't want to look at them ourselves, do we? So let's plug a large language model on the structured findings. And now we can make full use of what language models are best at, is looking through a lot of text and summarizing it for you and giving you a natural language user interface for asking questions about text. So how does this work in the background? So on the left-hand side, we've got a result that is automatically generated by an expert system, our own. The titles, everything is automatically generated. And in the background, we have some meta information for every slide. Let's assume we have 1,000 slides. Every one of those slides will have meta information about the patterns in there, the analysis, contextual information that is optimized for a large language model. And so the large language model, it sees this information and is able to query that kind of as its own knowledge base of all the findings in the analysis. And then, if we, let's say, have our 1,000 cross-tabulations, we know all the meta information, we know how they can connect across the dimensions, the patterns, the methods that were applied. We can connect it into a bipartite graph. And there are algorithms for traversing graphs. And this then allows us to connect dots between results and patterns. And this can be used as a foundations for actually storytelling. And so this is exactly the information that we offer to the large language model so that it can by itself answer your questions and actually give deeper kind of summaries of the results rather than just describing a slide. And so how would this interface kind of look like? Well, you feed all these automatically generated results as a knowledge base, you plug a large language model on top, and then you can essentially interrogate that data. This is our own interface. We offer these links. So every result fact that is stated here, there's a link to the actual slide where it came from, which is deterministically driven, and then it's always accurate. You can double check it. But we've also had a client that said, well, we don't want to use your product. We have, we're allowed to use Teams. We spent a hell of a lot of money getting this in place that all our employees can use Copilot and MS Teams. And so you just feed that into Teams. You can create, within a couple of minutes, your own Copilot agent. You can give it the knowledge base of a PowerPoint deck. And the meta information is actually stored in the speaker notes of the PowerPoint slide. And Copilot does really, really well at taking that. And I haven't actually seen a hallucination yet, given the right context and telling it not to make up numbers and all that kind of thing. So how does this work for our clients? So for one large research agency, they've been using it to automate their own process. Their data quality assurance, they're essentially checking for straight liners, speeders. They've told us that it saves them about more than 66% of their time. For all the analysis, cross-tabulation, regression analysis, saving them about 85% of their time because they're getting all the Excels done, all the slides done, charts done. On coding, we've got open-ended coding in place as well. This is saving them between 50 to 60% of their time. And client delivery, they haven't shared any information about that. They actually told us that they don't want to deliver automatically generated stuff, but they then spend time getting it into their own clients' themes and everything. And so that's probably where there's an opportunity to optimize further. And then some other cases we've got for using the large language model to actually generate stories and synthesize. We think it could save between 20 to 80%, but we haven't had that confirmed yet. So, can Gen AI be trusted with numbers? Yes, but with a hybrid architecture, not with LLMs alone. So, the conclusions are, with an expert system plus a large language model, you will get reproducible, accurate analysis. This will shift your time, rather than analyzing data and data processing, to actually being able to focus your time on storytelling, insight generation. Limitations, well, LLMs alone, they still struggle with reproducibility, and you do still have to check for hallucinations. That's why we offer the links to actually get back to the original result. You can't ever guarantee zero hallucinations. The current approach is limited to standard survey designs. I'm not sure, Andrew and Cameron, who presented earlier, I'm not sure in how far their solution goes to more complex survey designs, but that's still a bit tricky, and you still need humans in there to understand the data, understand which filters to apply. And the third limitation is you still need human interpretation, right? In the end, this is still a machine. It's still very stupid. It's just pulling numbers up. You need the human expert to interpret those results, and also apply the contextual information from their client, which is not available to the machine unless you provide it. Next steps, expand the setup to work on more complex studies, work with agencies to define best practices. I think it's still very much open for everybody to try things out. We had Steve earlier showing this wild hierarchical architecture of agents, Andrew and Cameron showing different things that they were trying, but I think we should try and work together and define best practices and standards for us trying to work on this kind of thing. And foster open dialogue. So thank you all for listening. Any questions?
Thank you very much. It's utterly fascinating. My big question is explosion of computation. So if you have 100 DVs and 100 independent variables, you end up with quite a number of computations required. So can you do it just in time, as it were? I'll pass over.
No, so it's not kind of real time. Essentially, it's a batch process, right? It's going to do everything by everything, and you have to do that to be able to. When I showed that kind of network graph of all the patterns, if you want to start putting the dots together, you have to do everything first. Otherwise, you don't know what all the patterns are, and that can take quite a while. So, a small analysis might take 2 or 3 minutes, but a more complex one could take half an hour to run through. But it's a one-time thing. Once it's done, then you plug a large language model on top, and essentially the answers are immediate if they have been calculated. If not, then you have to go back and rerun the whole thing.
Yeah, I was another victim of the winter of AI, and I worked for Accenture and loved every minute of it. Have you thought about using factor analysis, principal component analysis and correspondence analysis, to decrease the amount of tokens that you put in your model? Like if that's what it's designed for. Understanding correlation between closed variables or numeric variables and seeing what's independent, and maybe you could get real time with that. Have you tried it?
No, absolutely, yep. We will use these kind of analyses up front and even some heuristics as well to decide, well, this is just wasteful to do this, and then kind of ignore certain parts of the analysis that wouldn't be relevant at the end. Yeah.
My question, if it's a question, is you said that LLM cannot be done alone, okay, and you're working individually. So if you go back about, say, 1, 2, maybe 3 years ago, everyone was going on by LLMs as being the key thing. Have we not evolved in that period now to say that you can't work alone with it, you need to have other elements? That's a query. And then the other one is, like, you're saying that you want to work with other industry leaders on this. Why isn't the industry not working together on this? Because it's sort of like everyone seems to be working in silos with similarities. From today's presentations, I see some similarities. Why is the industry working all alone? Or companies like yourselves are working alone rather than as one?
Well, for one, most of our time we're sat behind the computer building the thing and not out here meeting. And so when we do come here, it's maybe once every year, or, I mean, this is my first time here. So I just saw Andrew and Cameron's talk earlier. I guess we'll have a chat. And so it's taken 3 years for us to meet. So it just, in the end, it takes time, right? You present these things, you meet up. You have to also spend 6 months a year going down the path yourself to learn. Realize it's the wrong one, try something else, and think, I think it's kind of normal that it takes time. Yeah. But I think we would have war stories and intellectual conversations about it, but the only way to really accelerate it is if somebody put a lot of money into it, which we don't have, and said, yeah, right, let's build this thing and faster than anyone else, or with collaboration with other people. However, we're in the end 3 developers sat at home building this.
Thank you. So you mentioned in your presentation that in 2024 you had like a 1 chance out of 2 of getting it wrong with Gemini or any of the other LLMs, and that's also what I could see. Now, even 6 months ago, you couldn't do like a 4-digit times 4-digit multiplication and get anything right. Well, now it can do it every time, correct, across all the models. And we're also seeing gold medal type of performances from LLMs. So my question is, we are building those very complex type of systems, and we are trying to do the same thing in my business, but are we not close to a point where LLMs are actually going to be able to do those things? I mean, they were rubbish a year ago. Now they are decent and starting to become actually good. And if you look at the progression, they are just 2 years old.
Yeah, I mean, in the end, it's still running. I believe it's running like code in the background doing those calculations.
Yeah, using tools, correct.
Yeah. And so, I mean, yeah, if the code is always correct, I mean, I use LLMs for coding, right? It makes me super productive, but there's never ever a time where it writes my code without issues. The other day, I had it write some really basic data processing stuff that I needed as a one-off, and it was almost right. It was so close, the calculations were so close that I was almost thinking, well, do I just let it go? I mean, it's so close. And when I dug under the hood, it was ignoring rows in the table, and I had to debug it. I don't believe you'll ever get to a point where it will always be correct. I mean, the more complex the problems you're trying to solve, the higher the chance there will be coding errors in there. They would just be harder to debug and harder to prove wrong, maybe.
Yeah, I mean, this, I heard someone saying that we were like 1,000 days from the tipping point where what we think and what we've seen through the presentations today as being like an addition, like an added value in the process, where we're actually going to become the biggest liability in the process, which is scary. But I think my instinct is that's probably right. But anyway,
Yeah, but then the business guys have to kind of say that they accept errors, and it's going to be a kind of risk versus reward decision rather than accuracy. And if businesses decide that, then yeah, maybe we've lost at that point. But until the businesses accept that kind of risk from LLM-driven results, I think we're kind of safe. Yeah.
Okay, thank you.
Any more questions? Sorry.
Thank you so much for the presentation. Quick question around, have you explored any other options for doing it in other ways?
Well, I mean, we do use LLMs for coding, and actually the expert system that we've built, some of the modules we actually use an LLM to derive the answer. So and some of those kind of reasoning decisions, sometimes it might just be a business heuristic. Sometimes it might be an LLM. Sometimes it might be the result of a regression analysis. So I think, yeah, I don't know. I believe that the architecture of an expert system is kind of sound, and if your architecture is just a few nodes within that expert system and all of them are LLMs, then it's kind of, yeah, the same thing that Steve was presenting earlier, in a sense. You still need to connect those nodes together. There's a human that's connecting them.
Okay, everybody, thank you. Oh, sorry.
Thanks. So, I think now I heard so many questions from the morning. So, some question about where we are headed to. Do we have proper expertise, right? Are we getting expected results from LLM, right? So there are gaps. So how to fill gaps, human gaps? So what I understand, what we use as LLM is still generative AIs. But on the corner, we can see people are developing generic AI. So still, if we ask a medical question, it will generate, through LLM, it will generate some sort of answer coming from a doctor, but it's not accurate. But they are going to build, they are in the sense, all these big companies going to build generic AI or general AI, which will be 99% accurate, the doctor's prescription or recommendation. So very next level will be, what I heard will be super AI, right? So even though we present all these LLM, the base is generatives. It will generate something, it mimics human thoughts. It's not accurate, but the whole landscape will change soon when the generic AI will come. So that's what I heard and read. So this is a question for all the audience. So what we discussed from the morning, where's the human expert will be replaced by generic AI? I don't know. So just open-ended question for.
I mean, my limitation was that it's still just stupid and just giving you numbers. It still takes a human to interpret that number and do something with it. And I think, as I was just saying, in the end, it's the business guys who need to make decisions. Do they go with an LLM result that they may be sure is 80% correct, or do they go with something that was more expensive, took longer, but is 100%? I think there'll always be a human. It's just how many humans will there be?
Yeah, and I think generic AI, I didn't go through the Gartner curve, because Gen AI is not the only AI in town. I mean, we know that, and there's new stuff coming through. I have a feeling we might be talking about generic AI next time, but let's see. So, thank you. Any final questions for you? Okay. Thank you very much, Guillaume.